Cauchy mean value theorem, the statement is, let f and g be two functions defined on closed interval a to b such that they satisfy these axioms. Like the first one is, both are continuous functions, both f and g are continuous on closed interval a to b. Second, both are derivable, means their derivative exists, derivable on open interval a to b. And third part is, derivative of g is non-zero for every element of the open interval a to b. Then if all these axioms exist, then there exists at least one point C belonging to open interval AB such that f of b minus f of a over g of b minus g of a is equals to f dash of c g dash of c. So this thing holds by Cauchy mean value theorem if the axioms are, these three axioms are true. See, first of all, both the functions should be continuous on closed interval, means on each and every point of this closed interval the values of f and g exist in a continuous manner, means there is no breakage in the graph. The value exists in properly at each and every point on the left hand side and right hand side. What is continuous means the limits at every point of the interval is existing, and limit is equal to the functional value of particular point. Like suppose if I am talking about a, so on a left hand limit does not exist, and on b right hand limit does not exist. Other than these two, each and every point of the interval the limit will exist both ways and will be equal to the functional value of the point. Like suppose c is the point, f of c will be equal to the limiting value of the function at c. And derivability means the function's derivative exists on open interval, means the derivative if not existing at the boundary, that's fine, but other than boundary it should exist on each and every point of the interval. By it's fine I'm saying, means if the functions are derivative on closed interval also, that is also welcome, because in closed interval the closed interval is the broad condition. Then this, we are asking for only open interval derivability. If it is existing on closed interval, that's also fine, that's the superior one, right? This one is the more restricted one. So at least at open interval we should get both functions differentiation and existing, the derivatives are existing for both the function at each and every point of the open interval. And third part is, the derivative of g should not take zero values. Why so? Because g has to occur in the denominator. If it takes 0 value, the derivative has to occur at the denominator. If it takes a 0 value on any value of the interval, then this criteria will not exist. It may go haywire because there will be existence of infinity on right hand side. So that's why the derivative of g should be non-zero for every point of the interval. Then there exists at least one point of the open interval AB such that this condition holds. So this is Cauchy mean value theorem. This is just the statement. So we are going to prove this thing also. The given conditions here, g of a is not equals to g of b by given conditions. See, this is also the point that occurs in the derivability. So since the derivative is not going to 0 on any point, and this is the point which occurs in the derivative part, and the function derivative is not taking 0 values, so that is why it cannot have the same value at the extreme points. G of a cannot be equals to g of b. To prove this, if at all, if suppose we have taken this as equal, g of a is equals to g of b, in this case, since g is continuous, since g is derivable, and g of a is equals to g of b, then Rolle's theorem axiom is satisfied. In this case, g will satisfy all the conditions of Rolle's theorem. Which states there exists at least one point C in the open interval AB such that g dash C is 0. So these are the axioms of Rolle's theorem. If a one function is continuous in closed interval, if that particular function is derivable on open interval, and with these two we have value of the function is equal at the extremities, g of a is equals to g of b, then all the three axioms of Rolle's theorem get satisfied. And by Rolle's theorem we can say there must exist at least one point in the interval open interval AB such that the derivative at that point goes to 0. So this becomes the contradiction to the third statement here. Derivative of g cannot take answer 0 for any value of the interval. So this is not possible. This will create hindrance to our given axioms of Cauchy mean value theorem. So that's why we cannot take g of a equals to g of b. So this statement is true. G of a here is not equals to g of b. So this is contradiction. And we arrived at the contradiction because we assumed this condition. That means this is not true, hence this is true. Thus our assumption g of a equals to g of b is wrong. Hence they cannot be equal. So we are done with first part of the proof, that the g cannot have same value at the extremities. Now we'll proceed further, and to apply Cauchy mean value theorem, there is assumption of one function that we need to take. So let phi be a function such that f of x plus a g of x, where a is a constant to be determined such that phi of a is equals to phi of b. We'll find a using this criteria. So this implies if I use this criteria here, so I'll be getting f of a plus a g of a is equals to f of b plus a g of b, and finding for a, collecting terms for a, so a will be f of b minus f of a upon g of a minus g of b. Since it's matching with the result of Cauchy mean value theorem, we just need in the denominator as g of b minus g of a, so we'll take a as negative. Negative of a is equals to f of b minus f of a upon g of b minus g of a. So we are almost done with the proof. We just need this a minus of a as the thing which was on the right hand side of Cauchy mean value theorem. So we just need to prove a as minus a as f dash c upon g dash c to prove the Cauchy mean value theorem. So treating this as equation number 1, now we'll apply Rolle's theorem on phi of x. How can we apply Rolle's theorem? Because phi satisfy all the axioms of Rolle's theorem. See, f and g are given as continuous function on closed interval ab. Phi is a linear combination of these two, so phi is also continuous on closed interval a to b. F and g are derivable on open interval ab, and phi is being the linear combination of these two is also derivable in open interval ab. And if we'll check phi of a is equals to phi of b, we have chosen phi likewise that it already satisfies the equality at extremities. Phi of a is equals to phi of b. So phi satisfy all the combinations or the axioms of Rolle's theorem, and it will give us the conclusion of Rolle's theorem that phi dash c is 0. And when we'll use the conclusion of Rolle's theorem on phi, we'll be getting value of this minus a, which is the actual value we need to prove for Cauchy mean value theorem. As simple as that. So since f and g are continuous functions on closed interval ab, therefore phi being combination of these two is also a continuous function on closed interval ab. Similarly, the second criteria, phi is differentiable or derivable on open interval ab, as f and g are derivable on open interval ab. And third is, we have already assumed phi of A is equals to phi of B. This one we have assumed. So this implies phi satisfy all the axioms of Rolle's theorem. This implies there exists at least one point C in the open interval AB such that phi dash C is 0. Now using this condition to find the value of minus A and replacing it back over here, we'll be getting the result of Cauchy mean value theorem. So there is one last step for this. Phi here is f of x plus a g of x. Taking derivative, it's f dash plus a g dash. Taking the value at c equals to 0. This implies f dash c plus a g dash c is equals to 0, and f dash c is equals to minus a g dash and f dash c upon g dash c as minus a. And this is equation number 2. Therefore from 1 and 2 we get the result f of b minus f of a. This was actually minus a, and this is actually from 2 it's f dash c upon g dash c, which combines these two, which is a conclusion of Cauchy mean value theorem. So this was the proof of Cauchy mean value theorem. Next we'll be doing questions based on the same.